Hello friends, welcome to our very first class. Now you see the problem with many of us is that while trying to clear the exam, we tend to mug up formulas, and when any twist comes in the exam, we go haywire. We are not able to understand it, we are not able to solve the sums. So before beginning any chapter, you should know the basic concepts behind them. Once you know these basic concepts, the formulas would come to you intuitively, and you would also be able to clear the exam very easily, irrespective of how difficult the paper is. So with this, let's start our first class, and that will be on time value of money, in which we will cover simple interest, compound interest, NPV, and IRR. Well, all these at the same time might seem that why are we covering two different topics at the same time. This generally paper covers in capital budgeting, and this is just the building block. So why? Because as we proceed, we will see how NPV, IRR, and CI and simple interest all are related. So with this, we will start time value of money, and no need to copy notes, means it will be provided in the link. It is given in the link itself below the video. So it's a Word file, everything is written there very comprehensively, so you need not copy the notes. So what do we mean by time value of money? So definition, if we see, the sum of money is worth more now than the same sum will be at a future date. Now why this would be? Due to its earnings potential in the interim. So it seems very difficult, but still, let's see. 1000. Suppose you are given rupees 1000 today, and if you are told you have an option, take this rupees 1000 today or rupees 1000 after 1 year. Which one would you choose? The obvious answer would be this. But why? Have we realized that by choosing this, we just had used time value of money? Why? Because this 1000, if we can invest, then we will get something. So suppose if I invest this 1000 today in a fixed deposit of 1 year at around say 6% interest. So at the end of 1 year, I would be having 1060 rupees. So this is nothing but time value of money. Now let us tweak the example a little bit. Suppose now I give you the option of 1000 today and rupees 1100 after 1 year. So basically we are implying that you either take 10,000 today or 1100 after 1 year. That is, you can earn 10% by foregoing rupees 1000 today. So now which one to choose? Well, if we see that we are investing it in FD at the rate of 6%, and here we can earn 10% by foregoing it. So 1100 seems better. But what if I told you that you can invest this rupees 1000 in a mutual fund and earn 12% per annum? Now, which seems better? So, what is the conclusion? Your rate of interest earned in the interim makes a lot of difference. So now friends, we just saw as to how a time value of money can invest our decision making. We use this in our day-to-day lives, but we do not realize it. So do we know that we just use the formula for simple interest in the aforesaid example? A 1000 invested today in FD at the rate of 6% earned us 60 rupees interest. Should come to you intuitively. 1000 into 6% is nothing but 60 only. So which formula did we use? So if we see, simple interest equals to principal into rate of interest into time and divided by 100. So now, why this formula? Principal is nothing but the amount invested. Your rate of interest is this. And time should be in years. And why this 100? Because to convert rate into decimal. So if we say 6%, then it should be 6 by 100. So simple interest. So this you need not remember. You just know that if you're investing 1000 rupees at 6%, say for 2 years, at the end of 2 years, how much you will get? 120 rupees. What's there to remember in this formula? But yes, we need this formula to maybe solve some sums where they give a twist. So it's always good to remember, but it should come to you intuitively. So as we were saying, now suppose you have to invest 1000 rupees today and you get 6% per annum. So what will be the amount at the end of 2 years? So simple interest equals to 1000 into 6 by 100, time is 2 years. So it will be 120. So this is the interest part. Now what will be the amount? Amount would be principal plus simple interest. 2000 plus 120, 1120. So now, what if I tell you instead of 2 years, I can invest only for 13 months? Now what we will do? Just convert this into years. So t is equals to 13 months is equals to how many years? 13 by 12 years. So simple interest would be, so no need to convert this into decimals because at the end you will be using a calculator, so where you can just enter this value. So simple interest would be 1000 into 6 by 100 and time is nothing but 13 by 12. So if we see the answer for this, thousand into 0.06 into 13 divided by 12. So your simple interest is 65. And then amount is equals to 1000 plus 65, 1065. Now again, if I say that the amount can only be invested for 700 days, again it's very simple. 700 divided by 365 years. So again your simple interest would be 1000 into 6 by 100 into 700 by 365. So again if we see 1000 into 0.06 into 700 divided by 365, so you get 115.07. Amount is equals to 1000. So 115.07 is equals to 115.07. Same simple. Well, if you have any doubts, do write it in the comments column, comments below the video. Now, does simple interest exist? Means we have seen that okay, you invest rupees 6, so you invest rupees 1000 for 6% in an FD, but does FD really give you simple interest? The answer is no. Then where can we see simple interest in real life? The only example that comes to my mind is a bond or debenture, where your principal does not change. So suppose you have invested rupees 1000 in a government security or a treasury bill. So here rupees 1000, we see simple interest. Apart from that, or in a corporate bond, because the amount invested remains fixed, or the face value remains fixed, because you earn interest on the face value. So more of bonds in subsequent classes, just to give you a flavor that simple interest do exist, but we find it very rare. Even our savings bank interest, what do? Suppose rupees 1000 we invest or keep it in a savings bank account which earns 4%. So at the end of 1 year, how much we get? 1040. Now what happens? This becomes your new principal at the end of 1 year. So your new principal at the end of 1 year. So we'll like to give many terms to many things. So just we say, okay, since this is a new principal, and what does this contain? It contains your original principal plus your interest earned. So what we say to this? That's how we come to the concept of compound interest. Now suppose, let's say, use this sum. We have not yet learned anything about compound interest till now, except that our principal keeps on changing. So we'll use the concept of simple interest only to calculate compound interest. Now suppose 1000 invested at the rate of 4%. So what would be the simple interest for first year? It will be 1000 into 0.04. Using this decimal, it's basically 4 by 100 into 1. So 40 rupees. So amount after 1 year, 1040. So what would be the simple interest for second year? Or let's not call it simple interest, call it interest. 1040 into 0.04 into 1. So what would it be? 1040 into 0.04, 41.6. Amount after 2 years is to 1040 plus 41.6, 1081.60. Now had this been simple interest, what would have been our answer? 1000 into 0.04 into 2, which becomes your 80 rupees, and amount would be 1000 plus 80, 1080. So what is this difference? 081.6 minus 1080, 1.6. What is this difference? Seems difficult. It is not. So how much interest we earned at the end of 1 year? 40. Now simple interest assumes that you just take this 40 and keep it with yourself. That is, you do not earn anything on this. No earnings. But in compound interest, what we will do? We will at least, this 40 rupees earned, we will keep in a savings bank account at least, if not invested somewhere else. So we will earn on this also for 1 year. So what we will earn? We will earn savings bank interest, which will be 1.6 rupees. So this is the difference. So the only difference between simple interest and compound interest is that your principal keeps changing after every time period. Now, why we have used time period? Because the time period can be 1 year, 1 quarter, 1 half year, or even 1 month, or even 1 day. There can be compounding daily also. So now, what if I tell you that rupees 1000 you have invested in a FD. I will not say FD, just invested for 4%. Similar example for 10 years. The rate of percent for 10 years. Now calculating this interest for first year, as we have seen in that 1 year, then 2 year, up to 10 year. Then we will have to calculate principal at the end of 1 year. Then this will become the amount after 1 year. Then this will become the principal for second year. Then similarly we calculate the amount, then becomes the principal for third year. So it will be computationally difficult. Conceptually wise, it's very simple. Basically your principal keeps on changing, but to calculate it becomes difficult. That's why we need to take help of the formula. So what do we see? Suppose amount after 10 years. How are we calculating? We are calculating, say, 1000 invested in 0.04 for 1 year. Okay, plus 1000. This becomes your amount after 1 year. And what is it? It is the principal for your second year. This is nothing but the principal for second year. So then what do we do in the second year? So this becomes your principal. So suppose I am not calculating this. So what will happen? This becomes your principal, 0.04 into 0.1 plus 1000, and you again multiply it with 0.04 into 1 plus 1000. So you see, it's not possible. So as we have seen, computing becomes very difficult. So why not let's use a formula? With the formula, amount is equals to principal 1 plus R to the power t, and R is in percentage. So now we can see the derivation, but that's not necessary. So what are we actually doing in this? If we understand this formula, so suppose after 1 year, our previous example only, what was our previous example? 1000 invested for 10 years. Okay, so amount after 1 year, what would it be? So 1000 invested for 4%, interest would be 40, and the amount after 4 year, it would be 1040. So let's put it in the formula. 1000 1 plus 0.04 to the power 1 comes 1040. Similarly, amount after 2 years, 1000 0.04 to the power square. What it would be? Now previous example answer was 1081.60. Not even computing this, because we know the answer from previous. So now what is happening? If we see, this is the major change. What is happening? 1000 we are investing for 1 year. We get the rate is 1.04 to the power 1. Similarly for 2 years, what is happening? 1.04 into 1.04. So this compounding effect This is the only difference between your simple interest and your compound interest. Now amount after 10 years. The reason for which we use the formula, because computing 10 years using this step, using the erstwhile simple interest and changing principal concept would have been difficult. So what would be 1000 1 plus 0.04 to the power 10. So now in calculator, how you would calculate it? You just take 1000 or leave 1000 first. You use 1.04 into, just press 1 into, this becomes your square, 1.04 square. So what does it mean? At the end of 2 years. Now just press equal to 3, 4, 5, 6, 7, 8, 9 and 10. So this becomes your 1000, and now just press into 1000. 1480.24. So this becomes your amount after 10 years. Now again, just to see the steps in calculator, what we are doing, 1.04 into, if you press it once it becomes square, then cube, then 4, then 5, then 6, then 7, then 8, then 9, then 10. So your answer is this, then into 1000, so 1480. So we have also seen how to calculate it using a calculator, because in the exam you will not be having any scientific calculators, you will be only having a basic one. So you must be aware of this. So we have seen how compound interest actually works like magic. See, so now what would have been the amount in this if it would have been simple interest? Just for understanding, let us calculate. 1000 into 4% into 10. It would have been 400 and amount would have been 1400, 1000 plus 400. Now see the difference between these two, 80.24. So this 80 would seem not so much, but just assume this amount would have been 1 crore, then it would have mattered. So we will see a famous quote of the legendary investor Warren Buffett. What did he say? My wealth has come from a combination of living in America, some lucky genes, and compound interest. That's the power of compounding we are talking about here. Now let's do a sum. You have invested 1 lakh rupees, a realistic example, in an FD at the rate of 6%. Mind you, FD, your interest is compounded quarterly. So what is the total amount? And interest earned after 1 year, after 3 years, after 6 months. Now what is the difference in this sum and the erstwhile sums we have done? There was compounded annually. In this sum it is compounded quarterly. So what was our formula? Formula was A P 1 plus r to the power t. Now in many books we will see this formula has been modified just to give you like AP 1 plus r, like say if we use the term time period, let's say given a symbol, suppose RA and then T into A. What does this A signify? The number of times compounding is done in a year. So we need not remember this complicated formula. We can just go with this formula itself. So what is the amount after 1 year? Suppose if we see amount is equals to 1 lakh rupees you have invested. What is your rate of interest per quarter? 0.04 is 0.06 is your annual interest. So just divide by 4. Why? Because this is getting compounded at the end of every quarter and time was 1 year, so just to multiply it by 4 also. The reason is because what is happening, this is getting compounded, or either say this is getting compounded 4 times for a year also. So how to use it on the calculator? Simple 0.06 divided by 4 plus 1.015 into 2, 3, 4 into 1 lakh. So what is the result? 106136 06136.36. Now had it been annual compounding, the answer would have been 106. Why I'm always demonstrating the difference? Just to give you the flavor of compounding, means how annual compounding to quarterly compounding earned extra for you, extra earnings. Now similarly, after 3 years, what would be the amount? 1 lakh to 1 plus 0.06 by 4. So if you see the original formula, it is principal 1 plus r to the power t. So in case of quarterly compounding, what does r become? R becomes r by 4. And what does your t become? T becomes t into 4. So that's it. If you remember this original formula also, you can easily solve the sums. To the power 3 into 4. So now what would be the amount? Just try to compare it yourself and see if you match the answer below. So again 0.06 divided by 4 plus 1. So here we are compounding 12 times. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what are we getting? Into 1 lakh. 119,561.82. 119,561.82. So till up to now, compound interest should become very clear to you. Now suppose after 6 months. So do not get distracted by months. Just you have to see how many times you are compounding it. So amount is equals to 1 lakh 1.06 divided by 4, then for how many periods you are compounding? You are compounding it for a period of 2, only 2, because in a year there can be compounding 4 times, and since this is after 6 months, so you are compounding it only 2 times. So now the calculation should be simple. Now directly I am using this 1.015 into equals 1030, this 1 lakh 1030 22.5. Now calculating the interest, which we have seen, just minus 1 lakh rupees from this. So what is 1561 1.82? Similarly, what is the interest part in this? 3022.50. Now for homework, I want you to do the same sum. What was the same sum? 1 lakh invested at the rate of 6%, compounded monthly. So I want you to calculate it for amount after 1 year, after 3 years, and after 6 months. Now where would you give me the answer? In the comment section. Let's see, have you been able to follow this concept of compound interest or not? So 1 lakh invested at 6%, compounded monthly. So just to give you a hint, how many periods you are compounding in 1 year? 12. And what does your rate of interest become? 0.06 divided by 12. So this should make it very simple. Just give your answers in the comment section. So all this about simple and compound interest. Now we come to a related concept, NPV. So how come NPV is related? Means you have told that okay, compounding, we are investing an amount and then we are getting, but NPV, okay, first well let's understand what is NPV. NPV is the net present value, and what we were doing in compounding, we were calculating the future value. So how come this are related? Okay, let's see. What was the compound interest formula? P 1 plus R to the power T. So this was your, what was this, or what is this? This is nothing but your future value. So what is this? P. P is your present value. Now how will you calculate this P? Simple. You have A divided by 1 plus R to the power T. Okay, confused? See, I am telling you, you invest 1000 rupees today, and at the end of 1 year you get 1040 rupees, assuming 4% interest. I am telling you, you know this figure 1040, and you have to know, tell me what is its present value. So this present value would be 1000, assuming your discounting factor is the same as the rate of interest. Okay, so what is this new term now? Discounting factor. This is your discounting factor. See, in compound interest, what we are doing, we are finding the amount. In NPV, we are finding the principal. So just to give you a flavor, suppose I get 1 lakh after 2 years. How much this 1 lakh is worth today? In compound interest, we are calculating how much this will be worth after 2 years. In NPV, we are calculating how much this is worth today. So that's how this, I wanted to introduce the concept of NPV, because it's nothing, just a reversal of your compounding thing. Here also we are seeing that compounding takes place, but you are using that compounding concept to calculate the present value, not the future value. So again, the aforesaid example we have seen, 1000 after 2 years at the rate of 4% compounded annually becomes 1081.6. Now what if I tell you that, okay, so now you tell me rupees 1000 is 1081.60. So what if I tell you, will you be interested to receive 1081.60 after 2 years by investing rupees 1000 now? So, okay, this will depend on your best possible investment opportunity. Now if I tell you, okay, the best possible investment opportunity for me is that I can invest it only in a savings bank account at the rate of say 4%. So this seems 1081.60 seems okay. I'm neutral towards it. I may also invest, because instead of not earning anything, let's say. But what if I tell you, you can invest the same amount in an FD account at the rate of 6%? Now this 1081.60, does it seem profitable? Because we already know that it is earning 4% only. And now the alternate investment for me is the 6%. So will I be comfortable? The answer is no. Why would I invest rupees 1000 now in an investment which would give me 1081.60 when I can invest in an FD which would give me 6%? So okay, intuitively we have got it. Intuitively we have seen the rate of return on the investment. Rate of return on investment is less than your required rate of return. Why required rate of return? Because this will depend on many things. Here we are assuming it to be dependent on your best available investment opportunity. So what is happening? Your rate of return on investment, which is 4%, is less than your rate of return, which is the best possible investment in an FD. Now if I say I can earn say 12% in a mutual fund, so then my required rate of return becomes 12%. So okay, intuitively sir, it is fine, but now let us see a sum on this. Means how do we know that okay, so intuitively it's fine, but in an example, suppose if we see rupees 55555 invested for 4%, 2 years, not 4%, becomes suppose 6 lakh. Now then to calculate this rate and then becomes computationally difficult for us. So just see a sum. Similar example, your 1 lakh invested at the rate 4% becomes 108. Sorry, what does it become? Okay, let's change the amount to 1000, since it will be computationally easy for us. 1081.60. Now if I say my required rate of return is 6%. We know that this is not profitable, but still, how do we see it mathematically? So what is your NPV? NPV is nothing but your present value of cash outflows minus present value of cash inflows. Okay. So what is your present value of cash outflows? Let's take it year 0, 1, 2. Your cash flow. Now what are you doing? 1000 you are investing today. So this becomes your cash outflow. That's why in the negative sign. And at the end of 1 year, how much you are getting? You're not getting anything. And at the end of 2 years, how much you are getting? 1081.60. Now you have to calculate the discounting factor at the rate of 6%. Why? Because my required rate of return is 6%. See, if your required rate of return matches your rate of return on an investment, then your NPV is the amount invested. But here, since both are different, so how much, since this is invested for, so how to calculate the discounting factor? So what we have seen, again, just to give you, like, to remind you, amount was P into 1 plus R to the power T. So your discounting factor is P becomes A into 1 by 1 plus RT. This becomes your discounting factor. So at the 0, how it would 0, what would be? So 1.06. Now again here we are assuming annual compounding. So you have 1.06 to the power 0. So anything to the power 0 is 1. And at the end of 2 years, what will be your discounting? At the end of 1 year, do we need to calculate a discounting factor? Okay, let's just calculate. So how we will calculate? 1.06 divided equals to, this gives you this. Now, okay, 1.06 divided, what does it do? Basically, it's just a shortcut. 1 divided by 1.06. How much you will get? This you are getting. So instead of writing 1 divided by, we just use this shortcut in a calculator. And if your calculator is not supporting this, buy a different calculator which supports this. 1.06 divided, again the similar thing, this is 1. And then, so what is the discounting factor at the end of 1 year? 0.9434. So make it round, use at least 4 decimal places so that this rounding of error does not give you a wrong answer. So once we pressed, now this is the second time. So what is the discounting factor? 0.88999. So what does it become? 0.89, rounding out to 4 places. So what is your cash flow then? Means discounted cash flow. It is 1000. This is 0. This I'm just using 0.99 to 1081.6 becomes 962.62. So as assumed, or as intuitively it was to us, if we just, so what is the net present value? It's 37.38. So is it worthwhile? No. How did we arrive at decision? Because the NPV is less than 0. If it would have been more than 0, we would have accepted it. So your NPV was less than 0. So that's why the investment was unacceptable. But do we really know why we rejected this investment? Why? Because we believed we can earn more by investing ₹1000 in an alternate fund or an alternate way. So that's why we rejected that. We will not keep our amount in savings bank, instead we will keep it in FD. So so everyone knows that investment in savings bank account will be less than an investment in FD. So but where do we actually use NPV? So before that, let us see just the definition of NPV. It is a capital budgeting analysis technique. Used to determine whether a long-term project will be profitable. Capital budgeting analysis, long-term project. Because for less than 1 year, unless it's compounding daily or else, we would not be interested in so much. 1 year, it would not make much of a difference. So that's why it's a long-term project. But will NPV be used only in capital budgeting analysis? The answer is no. It can be used in any concept that uses time value of money. Like just now we have seen, we just created a sum out of nowhere that you are comparing a investment made in savings bank account with an investment made in fixed deposits. So the concept remains the same. So why? An important aspect of NPV is that $1, let's say ₹1 invested today is not worth the same as ₹1 tomorrow, or ₹1 and tomorrow is not the same as ₹1 and today. Now again, I'm going back to the basic concepts. Why ₹1 earned today is not the same as ₹1 and ₹1 and tomorrow is not the same as ₹1 and today? Because you can invest this to get an amount greater than ₹1. That's why your rupee 1 earned today is more valuable than a rupee 1 earned tomorrow. So NPV again uses this concept. In the compound interest we have seen rupees 1 invested today is not worth the same as rupees 1 tomorrow, because you can invest this and generate returns. Similarly, rupees 1 earned tomorrow will not be the same as rupee 1 earned today. It will be less than rupee 1, because you can invest the current rupee 1 in an alternate amount. So now let's do a simple sum on NPV. Suppose a company, this is taken from Tata McGraw-Hill book. And now an interim question which might arise is whether you need to refer to the book. Always good, because once you understand these concepts and go through the book, your concept will become more clearer. But suppose due to paucity of time, you do not have time to visit the book, no issues. If you just watch these videos, take the concept with you, and then solve sums. The concept becomes stronger. Then you can easily clear the exam. So now a simple sum on NPV. Company invests rupees 1000 today to generate a cost savings of, assume this to be the cash flow. For taxation and depreciation benefit, we are not going into that much depth, nor is it required from the viewpoint of our exam. To generate a cost savings of 350 in year 1, 500 in year 2, 600 in year 3, 800 in year 4, again 800 in year 5, and 600 in year 6. So would the investment be profitable at the rate of 10%, at the rate of 20%? So now what we have to do, we have to calculate the present value of all these cash inflows, deduct the present value of cash outflow today to arrive at an NPV, using which rate? At the rate of 10%, the rate of 20%. So okay, let's get started. So what were we assuming in this? At the rate of 10%, we want to say that we can invest 1000 for 5 years at the rate of 10%, and we are evaluating whether this 1000 invested, whether this rupees 1000 invested at the end of 5 years, invested at the rate of 10% at the end of 5 years, would be greater than the present value of cash inflows, would be greater than the cash inflows, because here we are, this would be a future value. So we are trying to evaluate this in simple terms. So now let's just use this here, cash inflow, discounting factor at the rate of 10%, your present value. So 0, 1, 2, 3, 4, 5, 6. What was our net outflow? 2000. Inflow is 350, 500, 600, 800, 800, and again then 600. So both these things are given. What we have to calculate? We have to calculate just the discounting factor. So 1.1 to the power 0 is 1 only. Similarly, 1 divided by 1.1 to the power 1, how much will it be? 1.1 divided equals to, it will be 0.9091. 0.9091. Similarly, for 500, no need to calculate again the same step, just press an equal to. This will be 0.8264. Then for 3, what it would be, again an equal to 0.7513. Then again 0.6830. Then again an equal to 0.6209. Then again an equal to 0.5645. So what will be the PV then? 2000 into 1. This is nothing but your cash inflow into discounting factor. So it will be 2000. Similarly, how to calculate 350 into, so this will be 350 into 0.9091, 318.18. Again then 500 into 0.8264, 413.2. Again 600 into 0.7513, 450.78. 800 into 0.6830 will give you 546.4. Get 800 into 0.6209 will give you 496.72. Again 600 into 0.5645 will give you 338.70. So I've solved this sum with you just to give you a flavor as to how we can calculate this. So minus 2000 plus 318.18 plus 413.20, 450.78, 546.40. Oh, sorry, messed up. 2000. Just take it minus plus 318.18 plus 413.20, 450.78, 546.40 plus 496.72, 338.70. So what is your PV? 563.98. Up to 4 decimal places if you are using, you might get a little bit 1 or 2 rupee difference from the answer given in the book. Now, how we calculate at the rate of 20%? Again, the similar way. I'm just giving you the discounting factor. You calculate it on your own. So again, 1.2 divided 0.8333. So it will be 0, 1, 2, 3, 4, 5, 6. So it will be 1.8333. Again it will be 0.6944, 0.5787, 0.4822, 0.4019, 0.3349. So your answer at the rate of 20% would be, your NPV would be negative 105.65. So what would you do? Since your NPV is positive, you would accept the project, and here since your NPV is negative, you would reject the project. Now see this accept and reject is only changing because of your discounting factor. And what is the discounting factor? Your best available investment opportunity, or for NPV purposes it can also be your cost of funds. Now suppose if I tell you I can raise funds from the market at 20% only, and you want me to accept this project, it is not possible, because ultimately I will lose on the project. And suppose if a company can raise debt at the rate of 10% and invest in this project, it will be hugely profitable for the company. So that's why your discounting factor makes a lot of difference. In fact, it makes the only difference to your decision. Now this seems computationally 10%, 20%. Why not just have a single rate which we can use to evaluate? Because what we are doing in this, we are taking NPV at 10%, 20%. Now instead, just tell me your cost of funds and compare it with the IRR of the project. Okay, IRR, new concept. Yes. What the cost of funds, and compare it with the IRR of project. What is IRR? Internal rate of return. Okay. So, what is internal rate of return? What I told you, that you invest rupees 2000 and you get all this cash flows till the end of 6 years. Okay. So now what is IRR? Basically nothing. How much you are earning by investing 2000. We are earning this. No, what is the single rate that you are earning? Means if I tell you, instead of giving me all this, you give me a single rate as to what I'm actually earning in this. So that is nothing but your IRR. So that would become very simple. I would know the IRR in this, and then I would just compare it with 10%, compare it with 20%. So if IRR is greater than 10%, I would accept, else reject. So your becomes very easy. Now if it had been very easy, then why are we even doing the NPV concept? Because calculating IRR is difficult. So that's why we prefer to use NPV, which becomes easy. Okay. So okay, let's compute the IRR in our erstwhile example. So if you see this example, your 10% gave an NPV of 563.98. Your 20% gave an NPV of 105.65. So for IRR, you have to use guesses as to what rate would you use so that your NPV becomes 0. Becomes 0 means you invest rupees 2000 at IRR, your NPV should be 0. Okay. Now how to calculate this? Now suppose if I tell you how to, like, considering this 2, you would see 563.98 is too far from 0. Still 105.65 is approximately near. So let's take a guess of like maybe around 18%. When we will discuss the pass on IRR, I will tell you how to guess the IRR also. Means just to get an approximate, because the closer your IRR is to 0, the better your answer will be. So now suppose let's guess it at 18%. So again, I will not show you the detailed calculation because it will unnecessarily increase the length of the video. So again, year 0, 1, 2, 3, 4, 5, 6. Your cash flow is negative 2000, 350, 500, 600, 800, 800 and 600. Your discounting factor at the rate of 18% would be 1.8475, 0.7182, 0.6087, 0.5158, 0.4371, 0.3704. So your PV would become 5.46. See, it is very close to 0, but still it is not 0. And you need 2 values for calculating your IRR. Now see, at 18% it is positive and very close to 0. So the next is discounting factor at the rate of 19%. So now if we use, our NPV comes to 51.29. Obviously we could have used, say, because if we see 5.64, using a 1% difference makes it very wide. Otherwise we could have used like 18.1 or 18.2, but it would have been then computationally difficult. So okay, so what are we telling? At 18% our NPV becomes 5.64. Your 19%, your NPV becomes minus 51.29. So what will be your IRR? Let's say X percentage, so that your NPV is 0. Now we have to use interpolation to calculate IRR. See, I told you computing IRR was difficult, so that's why we use NPV instead. So how to calculate? See, your X lies in between this, and you have all the variables here except X. So let's just see, X minus 18, this minus this will give you 0 minus 5.64. Similarly, 19 minus X, what it will give you? It will give you minus 51.29 minus 0. So you have to solve for X in this. So if you solve it for X, your X becomes 18.10. So this is nothing but your IRR. Now okay, what to do in exam then? See, understanding the concept is very easy, but in exam, suppose if you are told that you have to compute the IRR of these cash flows and you are given options. Suppose A, they tell you 17%, B, they tell you 17.6, C, they tell you 18.1, D, they tell you 18.5. Then just use this 17% to compute NPV, which should be 0. Similarly, use this to compute NPV, which should be 0. If it is not coming to 0, this is not your answer. When you will use this, you will see that NPV is becoming 0. So this will be your answer. So in the exam, just do a reverse calculation and it will be easy for you. So in the current class we have seen NPV, IRR, compound interest and simple interest, and we have seen how these three are related. Your CI gives you future value, NPV gives you present value, and IRR gives you the rate which you are actually earning on the project. So we will discuss about NPV and IRR in future classes in the capital budgeting section. Next class we will start annuities and the other topics in chapter 1. So till then, keep reading, keep solving sums, and yes, remember the homework, post it in the comment section. Plus any doubt you have, and also your suggestions and comments on the video. So till then, see you, and do like and share and subscribe to the channel, because this will what keeps us motivated to make free videos for you which will help you to clear the exam. So thank you friends, just signing off for now. We will meet soon.